Hi everyone, here are your notes for adding like terms when it comes to radical expressions. So first let's just look at this little example here. So remember how before when we were multiplying we kind of discussed how the number in front is the coefficient and you can kind of treat this radical as a variable. Now that was kind of just a visual. They're not really like variables because they do actually have a value. So for this example, we have 2x plus 3x equals 5x. And we know that's true, right? Because they have the same variable. So we can just add our coefficients. Now in this case, if we treated our coefficients as coefficients, and if we treated these like variables, we don't have the same variable, right? So it makes sense that the square root of 2 plus the square root of 3 does not equal the square root of 5. So when you're multiplying and dividing, we'll get to that later, you can use the values on the inside and get to your answer. So if we multiplied them, we would have square root of 2 times square root of 3 equals square root of 6. We can do that. But if we had the square root of 2 plus square root of 3, it's not going to give me square root of 5. It doesn't work that way. But I'm going to show you how you can work these problems out using like terms. So for this first example, we have 6 to the square root of 6 square root of 3 plus 2 square root of 3. So if we treated it like variables pretty much, we look and say, do we have the same variables? Yes, we do, square root of 3 and square root of 3. So I can add them. So I'm going to have, remember, I'm just going to be dealing with my coefficients here. I can't add these numbers inside the radicals, so I'm just going to add the 6 and the 2, and that's going to give me 8 square root of 3. Just like here, I only added my coefficients. My variable stayed the same. All right, let's look at example 2 here. So I have 8 square root of 2 minus 6 square root of 2 plus 5 square root of 2. Do I have the same radical for each expression? I do, square root of 2. So I can go ahead and deal with these. I'm just looking at the coefficients. So I have 8 square root of 2 minus 6 square root of 2. So 8 minus 6 is going to give me 2 square root of 2 plus 5 square root of 2. I'm just doing it 2 steps at a time. Just 2 steps. So I had 8 minus 6 gave me 2. And then I am going to add 2 to 2 square root of 2 plus 5 square root of 2. It's going to give me 7 square root of 2. All right. Now let's look at this example here. I have 6 square root of 8 plus 11 square root of 2. Do I have the same radical? No, I don't. So here's what I'm going to do. In most cases, especially in this class and what we're going to cover here, you will be simplifying these. You'll be able to simplify these radicals, and you should be left with a radical that's the same as the other one you're given. So how would I simplify? You remember going back to simplifying radicals? I'm looking for 2 factors of this number here, 8, where one of them is a perfect square. So I have 6 square root of, what are 2 factors of 8 where one of them is a perfect square? Well, let's see. My factors of 8 are 1 times 8 and 2 times 4. Are any of those numbers perfect squares? Yes, 4 is a perfect square, so I'm going to use those. All right. Then I still just have plus 11 square root of 2 because I can't simplify that anymore. So now, when I simplify this, I'm going to take the square root of 4 here because I can do that. I know what the square root of 4 is. It's 2. So I'm going to take that out. So I'm left with 6 times 2 square root of 2. Because when I take that out, it's just left out here on the outside, right? Plus 11 square root of 2. Alright, so then I'm going to have 12 square root of 2 plus 11 square root of 2. Because when I pulled this square root of 4 out, it comes right outside the radical. Alright, so now do I have the same radical? Yes, I do. So 12 plus 11 is just going to give me 23 square root of 2. Remember, I only add the coefficients here, the numbers in front. Okay, let's move on. So first I check, do I have the same radical here? Can I add them? Can I add my coefficients? No. Square root of 45 and square root of 20 are not equal. So I'm going to have to simplify. So 8. So I'm asking myself, what are 2 factors of 45 where one of them is a perfect square? Some off the top of my head are 1 times 45, 3 times 15, 9 times 5. Are any of those a perfect square? Yes, 9 is a perfect square, so I'll use that one. Alright, hopefully we're getting the hang of simplifying these radicals here. So 2 factors of 20 where one's a perfect square, I'm going to use 4 times 5 because I know 4 is a perfect square, right? So here when I pulled out my square root of 4, I wrote it outside. In this problem, I'm just going to bring it out and multiply in one step. So what's my square root of 9 here? 3. So I'm going to bring out 3 here. It's like I'm pulling the square root out. So then I'm going to have 8 times the square root of 9, which is 3, so I'm going to get 24. Because when I take the square root of 9, it's 3, so I can pull that out. 8 times 3 is 24. So 24 square root of 5 plus, let's do the same thing here. Take the square root of 4, it's 2. So I can pull that 2 out. Now 7 times 2 gives me 14 square root of 5. All right. Now, do I have the same radical? Yes. So I can add my coefficients. So 24 plus 14, it's going to give me 38 square root of 5. And that will be my final answer. And hopefully you're kind of seeing a pattern here. Basically, we're simplifying so we can get the same radical here. Then we can add our coefficients. All right, let's move to this example down here. So I have 18 square root of 72 plus 2 square root of 98. Now, if you can't think of the right factors off the top of your head, I usually like to start with the small numbers. So I'll say, so I'm trying to simplify 72 here. So I've got 18. So I'm going to say, what's 72 divided by 2? It's 36. Is 36 a perfect square? Yes, so that one will work. So 36 times 2. If you happen to use different numbers, you just have to simplify, take a couple extra steps and simplify some more, which is fine. This way is just a little bit faster. So I usually start, 72 divided by 2. What's 72 divided by 3? And I see which one's going to give me a perfect square. So let's simplify 98 here. So what's 98 divided by 2? It's 49. And is 49 a perfect square? Why, yes it is. So I'll have 49 times 2. And like I said, if 2 times a number wasn't 98, what I'm trying to say is if this number right here wasn't a perfect square, then I would just keep going and say, what's 98 divided by 3, 98 divided by 4, and so on. Sorry, I don't know why that took me so long to get out. All right, let's move on. So 18 times square root of 36 times 2. So remember, I'm pulling out the square root of 36 here, which is 6. So when I pull out a 6, I'm going to have 18 times whatever I pulled out. I can write it out here if I wanted to. So 18 times 6, it's going to give me 108 times the square root of 2, because I took the square root of 36 out, remember? So all I'm left with is 2 on the inside. Now same thing here, I take the square root of 49, it's going to give me 7. So when I pull that out here, I have 2 times 7, 14 square root of 2. Now do I have the same radical? Yes, I do. So 108 plus 14 gives me 122 square root of 2. All right, and our last example here. So I have, none of these are the same radical. So what I need to do, I need to simplify. Okay? So like I said, what I like to do, I just start with 2 and then go down the list. So what's 128 divided by 2? 64. Is 64 a perfect square? Yes, it is. If you're not sure if a number is a perfect square, you can always go back to your list that we took at the beginning of our Simplify lesson, or you could just look up a perfect square chart on the internet. That'll be very helpful. But eventually, hopefully, we'll get these memorized and we won't have to do that much thinking about it. All right, now 18. What are 2 factors of 18? So I'll just start with 2. What's 18 divided by 2? Gives me 9, so 9 times 2. Okay, and what about 32? What's 32 divided by 2? Well, it's 16. And is 16 a perfect square? Yes. All right. And a good, another reason I like just starting with 2 is that usually if it does work for the first one, it'll work for the other 2. Because remember, once we take the square root out, all we're left with is the 2 inside. And that's our goal, to get the same radical. So remember, I'm pulling out the square root of 64. I'm going to pull out the square root of 9, and I'm going to pull out the square root of 16. Okay, so pull out the square root of 64. I know that's 8. So 2 times 8 is 16. And I'm left with 2 on the inside. Minus the square root of 9 is 3. I'm going to pull that out. And I'm left with square root of 2 on the inside. Plus square root of 16 is 4. I pull that outside. So 4 times 4 is 16. Left with square root of 2 on the inside. Now do I have the same radical? Yes. And you don't have to draw these, I'm just showing you every time that we do have the same radical at the end. So, since they're all the same, I can add or subtract my coefficients. So 16 minus 3, it's going to give me 13 square root of 2 plus 16 square root of 2. So 13 plus 16 gives me 29 square root of 2. All right, so first we need to check, do we have the same radical? If not, we need to simplify where we will have the same number under the radical. Then once we have the same number, then we can add or subtract our coefficients.